Okay, this is lesson 14, quadratic equations, solving quadratic equation, completing the square. Normally, in the past, when we solved a quadratic equation, we had to factor. But sometimes factoring is not practical. So we have to go to other methods, such as quadratic formula, or also using solving specified variables. Okay, here we have a quadratic equation, basically is x squared. So in order to solve, basically, this is what's known as standard form, where we have the highest exponent goes first, and then the next highest, and so on. Now, when we solve for a quadratic equation, we use what's called the zero factor property. Basically, when you have two factors, a times b equals to 0, then that means either a is equal to 0 or b equals to 0, or both of them equal to 0. So that's what we do when we try to solve for quadratics. We try to factor the quadratic equation and then set each factor equal to 0 and then solve from there. And that's where the 0 comes in, when we set each factor equal to 0. Okay, so here we have an equation, 6x squared plus 7x equals to 3. All right, so let's see what we can do with that. So, lesson 14, quadratic equations. And this is 1.4. So we have this problem. We've got 6x squared plus 7x equals to 3. Well, with any quadratic equation, first thing we have to do is set the equation equal to 0. Well, how are we going to set this equation equal to 0? Is it equal to 0? It's not, right? We got this 3 here. So we got to get this equal to 0. So what that means, we got to do something with that 3, right? We got to get it over to the other side. So we got to apply what? Minus 3 from both sides, right? And so we get 6x squared plus 7x minus 3 equals 0. Okay, so we've satisfied the first requirement, is to get it equal to 0. Okay, so we've got to do this every time. Now, you see how we have a leading term is 6? We want to see, is there a common factor that we can factor out of here? There isn't. But we always want to check that, because if it is, then that would make our life a little bit easier. Well, let's see if we can factor it. If we can, that would be great. Put our x's. All right, so go ahead and try to factor this. I'm not going to go any further than this. You guys try to do the rest of this from here. Remember, use your signs and then use your factor tables. Okay, well, what is the easiest set of factors to start with? Factors for 6 or factors for 3? 3, right? So let's just put 3 here and 1 here. So that narrows down to these two blocks. You may not be able to see that yellow too well. Factors for 6. Well, if we multiply a factor for 6 times 3, let's see. chances are what would be a more likely set of factors to use? 1 and 6 or 2 and 3? Harley? 2 and 3. So which way would you want to put it? Would you want to put the 2 in the first block or the 3? 3. All right, good. Put the 3 here. That means the 2 goes in the other one. Okay, are we done? What do we got to do now? Good. Check it. This is going to be 3 times negative 3 is negative 9x. And then this will be plus 2x. We get a negative 7x. Is that what we want? Do we want negative 7x? We don't, right? The number works out, but the sign's wrong. So what do we got to do? Change the signs. Good. Make the plus a minus. Make the minus a plus. Check it again. We get a plus 9x minus 2x. We get a plus 7x. That's what we want, and it checks. Okay, now we can proceed from here, right? We can go, and now what do we do? From here, this is where the zero factor property comes in. We set 3x minus 1 equals 0, and 2x plus 3 equals to 0. So step 2, let's see, now we had step 1 was set it equal to 0. Step 2, factor. So this would be step 3. Set each factor equal to 0. And then solve. And solve. All right, so here we have 3x minus 1 equals 0, so we apply plus 1. We're solving. We get 3x equals to 1. Divide by 3, and we get x equals to 1/3. Here, minus 3. And so we get 2x equals to negative 3. Divide by 2, and we get x equals to negative 3 over 2. All right. So at this point, we can go back and check it. And so we'll do this. So we said x equals 1/3 and x equals to 3/2. So let's see what it looks like when we check it in the calculator. All right, well, here's our calculator. All right, we know that our equation is 6x squared. Oops, no, I don't want to do that. 6x. Let me clear this, start over. 6x, there we go, squared, plus 7x, and it equals to 3. Well, what we want to do next is we want to, okay, so now what we want to do is we have a solution of 1/3, right? 1 over 3. And we're going to store that into x. Store it into x and hit enter. Okay, and we get 1/3. So now when we put that into our original equation, we get 3. So we can say that 3 equals 3. Okay, because our original equation, if we went all the way back up to here, is 3. So basically, when we substitute the 1/3 in, 6 times 1/3, parentheses squared, plus 7 times 1/3 equals 3. We get 3 equals 3. And it checks. Okay? So now if we go back to our calculator And this time, we go to second and enter. And we do that again. And this time, we're going to put in a negative 3 over 2. Negative 3 over 2. And we're going to store that into x. And so now we put that back into our equation. There it is. Hit enter. And we get 3 again. Okay? So whatever your other side of the equal sign was, okay, that's what you should get. Now you could have put it in here. You could have done it here and get 0. You could have done that too. But it's better to go all the way back to the original equation. It's always best to go back to the original equation when you check it. Okay? And so this would be like stating 6 and then negative 3 over 2 squared plus 7 times negative 3 over 2 equals 3, and you get 3 equals 3 and it checks. Well, instead of doing it manually, you can use the calculator. Okay, and the whole idea is to get both sides to equal. All right, questions with that? Okay. If x squared equals to k, then if we applied the square root to both sides, what you get here is x equals to the square root of k and a k, and x equals to negative square root of k. So you could also say here x equals to plus or minus the square root of k. For example, let's say that we have x squared equals to 9. Well, if we apply a square root to both sides, right, we get x equals to plus or minus 3. Well, let's see how that works. If we put where x squared equals 9, we put positive 3 in here, right? We get 9. But also, if we put negative 3 in there, we also get 9. So that's why it has to have that plus or minus in it, because they're both solutions. Okay? And if you leave out one of them, if you leave out the plus or minus, then essentially you've left out half the solution. Okay? So you have to have them both in there. All right? Questions with that? Okay. Try this. Go ahead and work this one out. We have x, we want to solve for x squared equals to a negative 25. All right, go ahead and solve for that. Problem is we've got a negative radicand. I hope we don't lose power. Tell you what, why don't you go ahead and exit out of your program just in case we lose power. It doesn't mess things up. Okay, problem here is we got a negative radicand, right? We know that I squared equals to a negative 1. So that means this is going to change to 25I squared, right? So therefore our answer is going to be x equals to what? Plus or minus what? Travis? 5I, right. Plus or minus 5I. Well, to check it, now this is how you can check this on your calculator. Okay? We're going to put in here parentheses 5, and then you see this I down here, second and I, close parentheses, squared, hit enter. There it is. See, it came up with negative 25. Okay? So this little blue I down here where the decimal point is, that's what you use for I. All right? And you can check your answers. All right, questions with that? All right. All right, well, let's say that we want to solve for x squared minus 4x equals to a negative 2. Okay? Harley, what do we do first? Okay, plus 2 plus 2. And we get x squared equals to 4, x squared minus 4x plus 2 equals to 0. Well, does it look like this is going to factor? Well, factors of 2 are just 1 and 2, right? Are they going to either add or subtract to give us 4? There's no way, right? So it's pretty obvious. We don't even have to try to factor. We know that's not going to work. So from here we use the quadratic formula. Okay, and so the quadratic formula given ax squared plus bx plus c equals 0 is x. Now, variable on one side, x is your whatever your variable is. Now, if your variable is y, then you put y here. If your variable is z, you would put z here, and so on. Negative b plus or minus the square root of b squared minus 4ac, and we want to make sure that goes all the way across, divided by 2a. And that's our quadratic formula. So we want to remember this. This is one of the most important formulas you're going to learn in the course. Okay, so for our original problem, we need to, first we want to identify A, B, and C. That helps. And I would even write it down. A, that would be 1. How about B? What's that? And you take the sign and the number. Sydney?
Negative 4.
Okay, negative 4. And C, what would that be? 2. All right. So if you get the signs wrong, then it's over. It's wrong right from the beginning. So it really helps to go ahead and write them down first. Okay, so this is going to be x is equal to, now you see how this minus sign here for the equation is a negative? And then for b, we also have a negative. So this is minus a negative 4 for the b. Plus or minus the square root of b squared, that's a negative 4 parentheses squared, minus 4 times a, we said is 1. B, or C rather, is 2. And that's all over 2 times a, which is 1. Now you have to be careful that you go all the way across with this line, because if you do just that, you see how this line doesn't go all the way across? That's wrong, because the 2 doesn't divide into it. You got to go all the way across. Okay? Questions with this so far? All right. So this becomes a plus 4. Plus or minus the square root, 4 squared is 16. Minus 4 times 2 is 8. All divide 2 times 1, that's just 2. So far, so good. So now 16 minus 8, that's 8, right? So that's 4 plus or minus the square root of 8 over 2. Well, the square root of 8 is going to be what? Well, it doesn't come out to be an even square root, so basically we got to split that, right? The square root of 8, if we do this off to the side, square root of 8 is basically factors of 8 are what? Two and 4, right? So this would be like the square root of 4 times the square root of 2. So the square root of 8 is going to be 4 plus or minus what? Square root of 4. Well, what's that? 2 square root 2 over 2. But we want to simplify that, right? So we can split it. 4 over 2 plus or minus 2 square root 2 over 2. And so we get 2 goes into 4 2 times. So that's 2 plus or minus, and then 2's cancel, the square root of 2. So you can either write it like this, or you can write it as 2 plus the square root of 2 and 2 minus the square root of 2. Okay? Questions with that? All right. Okay, we want to solve for 2x squared equals 2x minus 4. Okay, so Dylan, what do we do? Yeah, get it all equal to 0. Minus x, and plus 4, plus 4. And so we get 2x squared minus x plus 4 equals to 0. Okay? And so, let's see, factors of 4 are 2 and 4, or 2 and 2, or 1 and 4. So no way we're going to get a 1x to factor it. So we have to use the quadratic formula. Okay, so set up your a, b, and c and put it into your quadratic formula. And I'll write it here, negative b plus or minus square root of b squared minus 4ac all over 2a. All right, go ahead and do that. And while you're doing that, I'll work this out here. All right, well, it looks like we got a problem, right? What's our problem? So that means we got to do what here? We got 1 plus or minus the square root of negative 31 over 4. So now what? Dylan? Okay. And how do we do that? Okay, so that'd be 1 plus I square root 31 over 4. And that's all you can do to that. Now you could also write this as 1 over 4. You could split it. This should be plus or minus here. Plus or minus square root 31 over 4. Sometimes they like to put I down here like in the middle like that. And that's acceptable. You just don't want to put it, up here, because then it looks like I is a radicand. So I prefer to keep it before the radical, but you'll see textbooks will have it off to the side. Okay, just be careful. If you do it that way, be careful. Okay? And so you could actually write it either way. All right? Questions with that? Okay. This is actually a good place to stop. We've got literal equations to do, but we can pick that up next time. All right. Okay. So